This video will focus on solving linear equations that contain variables on both sides of the equation. So if you look at this equation, what you'll notice is that there are variables on both sides of the equations, but we start off with the same first two steps that we started off with when we were solving our multi-step equations before. So just like I did before, I'm going to utilize keep, change where appropriate. I am then going to distribute to undo any parentheses that are in the equation because I don't want the equation to have parentheses anymore if I can help it. So I'm going to distribute that 1/4. So my left-hand side, I'm not changing at all. That's x plus -5 is equal to 1/4 times 16x plus 1/4 times 60. And then just to help myself out, I'm going to do some calculations off to the side. So I have 1/4 times 16 over 1. Well, and there's an x in there. So this becomes 16 over 4, which is 4x. So I've rewritten that left-hand side first fraction to be 4x plus, and then I need to do the next one. So we have 1/4 times 60 over 1, which is 60 over 4, which is 15. So again, I've rewritten that second one to be 15. So here's where the problem is new. I've undone the parentheses by using the distributive property. And if I look at each side of the equation, what I'm going to notice is that 9x and -5 and 4x and 15 are not like terms. So there are no like terms that I can combine on the same side of the equation. So what I need to do instead is I need to start rewriting my equation so that I can get all of the x's together, because the only way to solve for a value for x is if I have one single x left at the end of my solving. So what I notice here is that I have a 9x on the left-hand side and a 4x on the right-hand side, and it would be really nice if I could combine them together. The problem is that as it's currently written, we can't combine them because they're not on the same side of the equation. So what we have to do instead is we have to essentially undo one of those x's from one side of the equation to the other. And I like to focus on the smaller one. To me, the math is just a little bit easier. So I think, okay, if I wanted to undo 4x on the right-hand side of the equation, I would have to add -4x. If I added -4x to this side of the equation, I would have 0 x's left on the right-hand side, and I would just be left with 15. Now, the key here is that whatever you do to one side of the equation, you must do to the other. So since I added -4x to the right-hand side, to undo the x's on the right-hand side, I also need to add -4x to the left-hand side. And so as I do that, 9x plus -4x becomes a positive 5x, and then that -5 is still there. So ultimately what we do is we undo so that all of the x's are on one side of the equation. We then undo so that all of the non-x's are on the other side of the equation. So here I'm going to add 5 to each side so that this -5 plus 5 becomes 0. And I'm simply left with 5x on the left is equal to 20 on the right. And then my final step is I need to undo the multiplication of 5 by dividing both sides by 5. So I find that x is equal to 4. So just to reiterate the process that we went through, we used the distributive property here in the first step. We then started and we noticed that we had x's on both sides, so we undid one of the x's to the other side of the equation. It doesn't matter which, you just have to pick which ones you're going to move. So we added -4x to both sides so that there were only x's left on the left-hand side. We then, from there, used our multi-step linear equation strategies to help us solve and find that x was equal to 4. So just like before, we're going to use the distributive property here to distribute this -3 in order to rewrite this equation so that it doesn't contain any parentheses. So the 8x stays over here. We then do negative 3 times negative 3x, which is a positive 9x, plus negative 3 times 5 is negative 15, and then we have that plus 6 on the outside. And notice that we don't distribute the negative 3 to the 6 because the 6 is not inside of the parentheses. Now, when I look on the right-hand side of the equation, what I notice is I have two terms that are alike and can be combined. So I'm going to leave the 8x as is and then leave the 9x, but negative 15 plus 6, that equals negative 9. So I can combine those two terms together. Then from here, I notice that I have x terms on both the right and left-hand side of the equation. However, since I only have one thing on the left-hand side of the equation, I'm going to try to move all of the x's to the left, which means I'm going to subtract 9x or add a negative 9x to each side. In doing so, these two cancel out and become 0. Then over here on this side, 8x and negative 9x become a negative 1x, and that's equal to negative 9. Then from here, our last step is we need to get x alone. I notice that x is being multiplied by negative 1, so I divide by negative 1 on each side, and I find that x is equal to a positive 9. So one final example for this video. Here I notice I have a lot of negatives to start, so before I even distribute, I'm going to go through and utilize keep, change, change. I notice here that I have a distribution of a negative 1. So I utilize keep, change, change, and then I move forward and say my first step in all of these linear equations in order to solve them is to distribute. So I start off and I distribute that 6. So I have 12x plus negative 30 is equal to, and then I have 8 plus, I'm distributing this negative 1 out. Negative 1 times 4x is a negative 4x. Plus negative 1 times negative 10 is 10. I then look on each side of the equation, and what I notice on the right-hand side is I have two like terms that can be combined together, the 8 and the 10. So what I do here is I leave the left-hand side completely alone, but I combine the 8 and the 10 to be 18. And then from here I notice that I have the right-hand side fully simplified and the left-hand side fully simplified, but I have x's on each side. So what I need to do is commit to one x that I want to move to the other side, and I'm going to pick this negative 4x. So in order to move that negative 4x to the other side, I need to undo it, and to undo it, I need to add 4x to each side of the equation. So as I add 4x to the right-hand side, those undo each other. As I add it to the left, I have 16x plus negative 30 is equal to 18. Then from here, I'm going to undo the order of operations that are happening to x. So on the right-hand side, if I focus on that right-hand side here, what I notice is that the first thing I would do to x is I would multiply it by 16, then I would add a negative 30. So I need to undo those in reverse. So to undo the negative 30, I need to add 30 to each side. So then as I do that, these undo each other, and you're left with 16x on the left is equal to 48 on the right. I then need to undo that multiplication of 16 by dividing both sides by 16. And I end up with x is equal to 3.